So I will be explaining the evolutionary processes through this flowchart that I made. So what is evolution? Evolution is a change in allele frequencies in a population over time. So in order to understand what this means, we need to understand what an allele is. An allele is a variant of a gene. In other words, an allele is genetic sequences that code for a particular trait. So, for example, if there was a genetic sequence that was AGTGA, and that one coded for blonde hair, then anyone with that particular sequence would therefore exhibit blonde hair. So patterns. Patterns are anything that you can measure and observe. So for example, the color of a bird's wings, the amount of stripes it has, the size of its beak. If you can measure it, you can observe it, it's a pattern. And patterns are explained by processes. And the 4 evolutionary processes are natural selection, genetic drift, gene flow, and mutation. So I will start with natural selection. So what is natural selection? Natural selection is most commonly referred to as survival of the fittest, but what exactly does that mean? That means that some traits are favored over others. So for example, if there's a population with birds with large beaks and birds with small beaks, and there are only large seeds, then it makes sense that only the birds with large beaks are able to bite open the seeds or the large seeds. And the birds with small beaks are not able to open them, and they do not survive and reproduce, and therefore they die off. So when a trait is favored, then the allele for that that codes for the trait. So when when a trait is favored, then the allele that codes for those traits increase in frequency over time. And therefore, those traits become more common in the population. Then it is important to notice that evolution occurs in populations and not individuals. However, natural selection can act on an individual, and this causes a change in population over time, which leads to evolution. Going back to our bird example, if a bird with a large beak can only eat large seeds, it will survive and reproduce, and over time, although natural selection is only acting on that individual, over time, as that bird with large beaks reproduces, its offspring and its offspring and so on and so forth, they will all have large beaks, and pretty soon a majority of the population will have large beaks. So requirements for natural selection are the individuals must vary, the trait must be heritable, only some offspring will survive and reproduce, and the surviving individuals are not random. So the 4 modes of natural selection are directional selection, disruptive selection, stabilizing selection, and balancing selection. Directional selection is when there is a change in the mean phenotype. So say that this is the black curve is the initial population, and you can see here that birds, let's say this is small beaked birds on this end, large beaked birds on this end, and medium-sized beaked birds in the middle. So the initial population has a majority of medium-sized beaked birds. And let's say that in the vicinity where they live, there's only large beaks. Therefore, the change in mean phenotype will change towards the large big birds because only they can crack open the large seeds. And the same can be said if the small beaked birds become more favorable. Then the mean will shift to the left. And directional selection reduces genetic variation because all of this right here, when the mean phenotype moves to the right, then all of this variation is lost. And disruptive selection is when the extreme phenotypes are favored. So here we can see that it changes from, again, the medium-sized beaked birds being a majority of in this population. It changes to being mostly composed of small beaked birds and large beaked birds. And this, in fact, increases genetic variation because you have a whole lot of variation right here and a whole lot of variation right here. Although this variation right here is lost, well, it's not really variation because you still have medium-sized beaks right here. So that variation is not lost, but this variation and this variation is gained. Therefore, it has a net gain of genetic variation. So stabilizing selection is when it favors the intermediate phenotype, and this causes a reduction in genetic variation because this variation right here is reduced and this variation right here is reduced. It is mostly the medium-sized beak birds and these smallish beak birds and these large-ish beaked birds, they're all gone now. And balancing selection is when no single phenotype is favored at all times. This is due to the heterozygote advantage. It's when the environment changes over time, and it is due to the frequency-dependent selection. So under natural selection is the umbrella of sexual selection. So intersexual selection is mate choice. So intersexual is between the two sexes. So a male chooses a female and a female chooses a male. Intrasexual is, for example, male-to-male competition where two males fight over one mate or territory, so it's between the same sex. So the fundamental asymmetry of sex. So this leads to a difference in, I guess you could call it priorities for the male versus the female. So the male wants to produce so the male can produce a limitless amount of offspring. So their goal or their fitness depends on the number of mates it gets because the male's primary goal is to try to have as many offspring as he possibly can, therefore mating with as many mates as he possibly can. Whereas the female has a limited amount of offspring, and her fitness depends on the quality of her offspring. So she doesn't want to just choose some random male that has bad qualities because then her offspring will die off. She wants to choose a mate that has good qualities that she can pass on to her offspring, and her offspring will survive and reproduce. So a primary sexual trait are the sex organs, which is self-explanatory, and secondary sexual traits are traits that differ between sexes, and this underlies mate choice and males to do well in male-to-male competition. An example of this is male deers have antlers and female deers do not. If a male deer has really big antlers, they can A, attract the female who likes big antlers, and B, they can beat that the other male deer who has smaller antlers because they have bigger and better antlers. So the predictions of sexual selection are females are choosy. So again, the female must choose a good mate that has good qualities. Also, if an equal number of males and females are in a population, then the males must compete for the female. That goes back to females are choosy. So the female won't just choose any male. So the male must prove themselves that they are worthy enough to mate with that female. So they must compete. And lastly, if male fitness is limited by mating success, alleles that increase attractiveness or success in male to male competition should increase in population. So going back to the deer, that male with big antlers gets the female, and that female will have offspring that have the big antlers. And that offspring will have offspring that have big antlers, and they'll just keep going and going. And sexual selection is an example of non-random mating because, again, females choose the male that they want to mate with. All right, so we will go to genetic drift now. So genetic drift is an increase or decrease in allele frequency by chance. So an allele lost results in decreased genetic diversity. So an example of genetic drift is there is two populations of beetles. They both are coexisting, and so there's brown beetles and there's green beetles, and there is someone who is just walking through those beetles, and they just step on random ones. They're not stepping on all the green ones, or they're not stepping on all the brown ones. They're just stepping on random ones. Therefore, the increase or decrease, in this case a decrease in allele frequency, is by chance. And since you are stepping on just random, since you are killing the beetles, then you are removing them from the population, and therefore they cannot contribute their genes to that population any longer. Therefore, genetic diversity is lost. Genetic drift is stronger in smaller populations. For example, if you had 10 beetles and you stepped on 9 of them, then you would have one beetle left, and that beetle is all lonely and it can't reproduce because it has no one to mate with because it's all alone. Whereas if you had 1,000 beetles and you stepped on 9 of them, then you would still have 991 beetles left. They have plenty of options to mate with, and they'll be just fine. So it has a stronger impact on the smaller populations. So there are two types of genetic drift, and that is the population bottleneck and the founder's effect. So the population bottleneck is when there is a sudden reduction of number of different alleles in a population. For example, if there is an island and beetles are on the island, and all of a sudden a hurricane comes and just kills off random beetles. The hurricane isn't going to choose like, oh, I'm just going to kill all the green ones or whatever. It's random. So then again, the ones that die, they no longer contribute their alleles and their genes to that population. So it is so that therefore leads to a reduction in genetic diversity. So the founder's effect, that is when so we have a population of, let's say, birds, and in that population there's 1,000 birds, and let's say 5 of them decide that they don't want to live in that population anymore, and they just want to go and create their new one. So they fly more west. Then they colonize and they establish that small and isolated population, because they're a lot smaller, because that population of 5 is a lot smaller than that population of 1,000, and they have isolated themselves from that population. They're just by themselves, just chilling there. This also reduces genetic diversity because whereas before there was 1,000 birds and just endless amounts of genetic or different types of genes, now they only have 5. And so the rest of the 995 birds and what they contributed, that's no longer there. So that's why there is a reduction in genetic diversity. Okay, so now going to gene flow. So gene flow is the movement of alleles from one population to another via migration and mating. This leads to more similar allele frequencies between populations. For example, we have a mainland bird population and a island bird population. And a bird from the mainland decides to fly over to the island. So that's migration. And then that mainland bird decides to mate with the island birds. So since that mainland bird is bringing mainland traits over to the island birds, then the island birds will start to get more and more mainland traits. Therefore, the mainland birds and the now newly incorporated mainland traits into the island birds, they will become more and more similar as more generations pass on the mainland traits. And it is important to note that gene flow within populations increases genetic diversity. So that island population, when a mainland bird comes to them, just looking at the island population, they now get like, ooh, yay, we get new genes. We'd never seen mainland genes before, so their genetic variation gets increased because there's an outsider coming in introducing new genes to all of them. Whereas gene flow among populations decreases genetic diversity. Like I said before, when the mainland bird comes over and starts to mate with the island birds, and the island birds start to get the mainland characteristics, and both the mainland birds and the island birds have mainland characteristics and traits. So now they both have mainland, and now they're more similar. And genetic diversity between the two populations has decreased. And finally, we come to mutation. Mutation increases genetic variation. It introduces new alleles to every individual in every population in every generation. So mutations are due to a change in DNA sequence. And it is totally random with respect to fitness. It can be deleterious, which is bad, beneficial, or it can have no effect. But oftentimes it is deleterious. So if the mutation is deleterious, it can have a negative effect on the fitness of an individual, and therefore that individual will be eliminated by selection. For example, if there is a population of or there's a colony of bacteria and all of them are resistant to an antibacteria, then yay, they're all surviving and reproducing because they have nothing to kill them. But when one particular bacterium develops a mutation that totally blocks the resistant gene, then they no longer express it, and they are all of a sudden killed by the antibacteria. And so that is why they are eliminated by selection, because the trait of not being immune to the antibacteria is not favored. so of course it's gonna die. And if the mutation is beneficial, it will have a positive effect on fitness. Um, the and this will increase, so the trait will increase in frequency because individuals with the mutation will produce more offspring. So let's say the situation with the bacterial colony is flipped. So all of them are not resistant to the antibacterial, and all of a sudden one of them develops a mutation that allows it to be resistant. Um, then that bacteria, that particular individual, will be able to survive and reproduce and pass on its um, immune trait to its offspring, and then those offspring will be able to pass on to their offspring, and so on and so forth, until basically the whole colony is just all immune. Um, so yeah, and without mutation, there would be no genetic variation, and evolution would stop. Um, and yeah, so mutation has a big effect on bacteria because they can replicate quickly. Um, yeah, they replicate, what I think they said, every 20 minutes. So because they replicate so frequently, they are more likely to develop that a mutation. Whereas humans, we reproduce not that many times in our life, and we so if one human develops a mutation that is deleterious, then it won't have a big effect on, or we'll go with if, scratch that, sorry. So if a human develops a beneficial mutation, then it'll take longer for them to pass it to others because humans don't reproduce as frequently as bacteria do. So yes, those are the 4 evolutionary processes. Thank you and have a good